Okay, today we're looking at the notes for systems of equations. So, what is a system of equations? A system of equation is just equation having two or more equations. In class, we're only going to look at having two equations, but yes, you could have two, three, four, five, six equations. What is a solution to the system of equations? The solution for a system of equations is going to be an ordered pair that is true for all of the equations in the system. So if you had multiple equations, you had three or four, it has to be true for every single system. Okay. So there are three types. There are three types of solutions. There are first one solution. So when we have a system of equations, one solution is where they cross together. This point here is 2, negative 2. You have y equals x minus 4. That's this line right here. I'm going to call that y1. And this one's y2, which is negative 1 half x minus 1. Where they cross is at 2. We know this at 2, negative 2, because we know this if we plug in 2 here. 2 minus 4 is negative 2. So that checks out. We plug in 2 right here. 2 times a half, that's negative 1. Minus 1 is also negative 2. So because they have the same solution for the same, they have the same solution for the same input value, therefore that is a solution to all of the equations in the system. There are two equations. This is the ordered pair, 2, negative 2. That is the solution to the entire system. This is the place where they overlap. We can have no solutions when we have parallel lines. Parallel lines, they have the same slope. So therefore, there are no solutions. And then we have infinite many solutions. And this is when the line is on top of another line. So you'll see this sometimes. One will be given sometimes in like standard form. The other will be given in slope intercept form. If you want to go ahead and convert this to slope intercept, you would subtract this x over and you'd have y equals negative x plus 1. So they are the exact same line. So the reason why there's infinite many solutions is because they are touching at all of these points. The majority, 90% of what we're going to deal with is going to be right here. Okay. Sometimes we'll have no solutions. Sometimes we'll have infinite solutions. And in one lesson, we're going to have inequalities. So we're going to have like a shaded region. Okay. That's going to have solutions, but we'll wait for that for another day. So right here, we just have to identify the solutions. So for this very first one, they do not cross. So there is no solution. Here, they cross right here at this point. This looks like 3, 1, 2, 3, 4. 3, 4. Right here, it looks like they're about to cross. If I extend this line out and I extend this line out, it looks like they cross here, which is about 1, 7. On Desmos, you would just be able to click that dot and it will tell you what point it is. And here it's negative 3, negative 5. So this is how we solve by graphing. So to solve, this is going to be the most common way that we're going to solve. So we need to graph each equation. In Desmos or on a coordinate plane. Estimate the solution. Then check the solution. So here, I can't graph this in Desmos just yet. I have to solve. I'm going to actually move this y over because it's negative. So this becomes x equals y or y equals x. So y equals x is our parent function. Go something like that. I'm going to go ahead and subtract x over here. This is y equals negative x plus 4. So over 1, down 1, over 1, down 1. So my solution looks like it's 2, 2. So I did step 1, graphed. Estimate my solution, 2, 2. Now I'm going to check my solution. So I go back to the original. I'm going to plug in 2 for my x value and 2 for my y value. 2 minus 2 is 0. That works. That works for this equation. That means that this line is graphed correctly. I'm going to plug in here. 2, 2. 2 plus 2 is 4. That means this line is graphed correctly. So this point exists on both lines. I graphed them both correctly because when I plug in the points, the equation is balanced out. So therefore, because the equation is true, because these are solutions to the equations, they exist on the line. Therefore, the solution is 2, 2, because that is a point that both of these equations have. This one, we'd have to move x over, y equals negative x plus 4. I don't have to do anything with this because it's already in y equals. What I'd want you to do is I'd want you to go ahead and graph this in Desmos and then plug it in on your coordinate plane, and also make sure you write your solution. This one, I'm going to move my x value over. This one's already set. So I have negative 2 equals negative x minus 2. Divide everything by negative 2. This becomes y equals negative divided by a negative makes a positive 1/2 x. Negative divided by a negative makes a positive, so that's plus 1. So this is right here, and my slope is 1/2. So every time I go up 1, I go over 2, up 1, over 2, up 1, something like that. And I look here, and it's the exact same line. So this has infinite many solutions. So we could just write all real numbers. And I want you to graph this and find the solution to this. Thank you so much.